Hello viewers, today I will show you how to do a Schlenck reaction, like especially the palladium catalyzed reaction when you do like Suzuki coupling or any other like egg coupling or like Shonogashira coupling. So you have to use the palladium catalyst for that reaction, and especially it is very important those reactions not to be like air contaminated or like there shouldn't be any oxygen presence or something. So this is actually the Schlenk tube I'm using here. So this in this tube I added all my starting material, base and the solvent and the liquid catalyst and the ligand. So you can open these things, and while you are adding the things, so with this tube you can add your gas line, and you have to add those things under argon. So you will open it, make a funnel, then add everything there under gas, and then close this one. And after that you have to degas it with the vacuum line. So with the double manifold, so one side is gas, another side is vacuum. So give the vacuum to remove all the oxygen from here, and you can also do the freeze-thaw pump style. Like what is it, freeze-thaw pump? So once you add everything like starting material and all other materials, solvent, everything, then you have to close it completely, this tube completely. Then you have to freeze this whole thing in liquid nitrogen for 5 minutes. So after 5 minutes, then everything will be like solidified, and then with the tube connection, and then you have to open the vacuum part. You can open this one and vacuum. So all of your starting material, solvent, everything will be solidified under in the liquid nitrogen container. Like you have to put the whole tube in the liquid nitrogen, and then you have to give that vacuum, so all oxygen or gas inside it will be gone, and keep it like 3 minutes. And once 3 minutes is done, then you have to close back all the way down. Like if you see, this is closed now, like this line is closed. So after closing it, then make sure that there is no vacuum. So keep the line vacuum, like vacuum side on while it is connected, and then it will then put the whole tube in the water container, so that the solidified all its starting material, solvent, everything can go to its liquid condition. Once it is liquid, then wait 5 minutes, and after that again transfer the whole tube in the liquid nitrogen containing container and re-solidified again. And then once it is solid, like after 5 minutes, then you can remember that the connected tube should be like connected, and definitely this is not the correct one. Actually we can do in other hood. So suppose it is connected here, but always like vacuum is on, so the vacuum side is on and it is connected, and then immersion in the liquid nitrogen container, and then solidified, and then you can open it again while it is solid, open it again and give the gas, degas, like vacuum, and once you keep it in like 3 minutes, then close it again, and then remove it and put it in the water again to make it liquid again. So this will be like 3 cycles. So this is like freeze-thaw pump method, but ultimately I did this before. So here I'm showing now the reaction is done. So I'm gonna show how to start workup of this kind of reaction. So this is closed, and I used a shield before this reaction. So I stop the temperature now. So I'm gonna lift it up from the well bath, and I will let it cool down for room temperature first. Once it is room temperature, then I will open it to work up. So basically to work up, I will just pour the liquid part, whatever amount I have, so I'll filter it, and also I will wash with the DCM, and then filter the DCM part, because I know my compound is soluble in DCM, so the compound produced in this reaction, it will be coming with the DCM, and I will filter it, then I will load up the solution part and I will get the crude. So this is very easy and simple technique, but you have to be very careful if you really want to do the freeze-thaw pump cycle. And this Schlenk tube especially made for this kind of palladium catalyzed air sensitive reactions. So if you have any question about air sensitive palladium catalyzed reaction setup, you can ask me in the comment, or you can contact me. I'll reply all of your answers. So here I have taken out the tube, Schlenk tube, from the original reaction of well bath, and I wiped out the residual oil outside this tube with a paper towel, and then I leave it in the beaker to cool down to room temperature. So once it is like cool to room temperature, then I will open this knob very slowly, and initially you might hear some like hissing sound, like because of the build-up pressure inside this tube. And always you have to be careful before setuping this reaction, and also once wait until the temperature reaches to its desired value. So this reaction was actually in 85 degrees Celsius, so I stopped it, and now I'm waiting for the cooling down. And definitely you have to use a shield like this in front of this reaction area. So I used it before I stopping the temperature, and also I removed this shield before stopping the temperature, like after stopping the temperature, and now I'm waiting for the cooling down these reactions. And this is a very good techniques, and also like more successful, especially in the palladium catalyzed reactions. So any organometallic reaction, organometallic catalyst, or palladium catalyzed reaction, you can definitely use these Schlenk tube techniques. So I'm gonna open this because I already keep it for a long time, like 90 minutes. Sorry, 20 minutes. So it is like I can touch this with the, like, it is not hot enough, like now it is room temperature. So I will open it and I will start working up. Working up is very easy, it just depends on your procedure, how you are going to use it. If you have the base, then you have to maybe neutralize it as aqueous HCl solution, or like any other aqueous acid, or like you can just filter it. It depends on your procedure, how you are going to isolate your crude product to purify through column or like recrystallization. That depends on like different chemistry. But once your reaction is done by the Schlenk tube, so you can do this way, like cool it down, open very carefully this cap, and then just filter it, or like quench it with the 1 molar HCl solution, and then extract it with the DCM or like ethyl acetate, whatever the solvent preferable. So there are basic things like if you have the solvent for this reaction is like lighter than water, then I would normally prefer to extract the solution with the ethyl acetate, because ethyl acetate will be on the top of the water, and also your solvent will be on the top of the water. But normally people also do use DCM for extraction. In that case, your compound will be in the bottom of the water. But if you have lots of solvent, like which is lighter than water, then it will be like kind of troublesome. It will give you the like mixture of 2-3 layer or something. So to avoid that situation, I normally prefer, if your reaction used solvent is lighter than water, then use ethyl acetate for the extraction, because ethyl acetate is also lighter than water. So both the solvent will be on the top, like in organic phase, like your compound will be in the organic phase, and water will be washed out your undesired water soluble impurity or like base, everything. And also if you use the 1 molar HCl solution or any aqueous HCl solution or aqueous acid solution to neutralize the base, so those inorganic part will be gone with the water, like washed out with the water. So if you want to know about more extraction process, or like how do you do the how can you do the extraction, in my channel there are like 2 different videos for the extraction. You can maybe watch those videos to see the extraction. Okay, here I'm gonna show you how to work up with these reactions. So I'll open very carefully. If you see, it is cooled down, so I will work up this cap. Now it is safe to open and safe to pour. So I'm gonna take a funnel, and or since I have the base inside this reaction, so I'm gonna neutralize this reaction with 1 molar HCl solution to neutralize this reaction. So here I have pre-made 1 molar HCl solution. So maybe I can make this camera close to see how I'm going to set up everything here. You have to have the PPE like gloves and like the safety glass and the lab coat while you are. So I'm gonna use the HCl. Like I will add carefully HCl solution, very carefully here. So you might see some effervescence creating inside it. So you have to be careful and neutralize, shake it. So when it is forming this bubble, you have to be careful. Don't add all together. Just make sure that it is getting neutralized, and sometimes it can pop up. So you have to be careful and try to do like this. And clearly you'll see like 2 layer, water layer and the top organic solvent layer. So my compound should be in the organic top layer. So I will add a little bit more HCl so that all the bases getting neutralized. And you see like yellow color bubble is forming here. And I think this is enough. This is a big scale reaction, so I think I added around 100 ml, 80 to 100 ml of the 1 molar HCl solution. So now I'm gonna transfer this liquid in a separatory funnel, and I'll wash this tube with the ethyl acetate. As I told you before, like I choose because my organic solvent is on the top of the water, so I will choose the same kind of solvent so that my solvent will be on the top. So here I'm going to use like ethyl acetate for the extraction part. So let me take the separatory funnel. Okay, before using separate funnel, couple of things you always need to remember. Make sure you take some water and don't dripping anything. So that is one way to protect your crude not to spill. So I already checked. This separator funnel is very nice. So, and before pouring this thing, make sure that it is closed. Again, make sure that it is closed, and then you will pour this liquid through here, as I'm doing now. You can see. Definitely you can use a ring for the separator funnel, but right now, since I'm making the video also, I'll put it later, but I can wash with the ethyl acetate this bottle. So as you see, like I'm using ethyl acetate to wash out my tool from here, and once it is done, so I will just do like this and try to add here. And I'll do like these things couple of times to make sure that everything is here. Okay, then very carefully you can keep this flask in the hood in a safe place, because otherwise it may fall down and break down. And I will add a little bit more acidic solution to make sure that this solution is not lazy. So, and then I'm going to use one of these stopper, and before that I always check like if it is fit nicely, and also I invert it to make sure that it is not dripping before pouring your liquid. I already checked it, but make sure that before pouring your crude, you check your stopper with some water and invert your separator funnel and make sure that it is not leaking. If it leaks, then it will be problematic for your workup, because you may lose all of your product. So I will now, I'm gonna add a ring here to use the separator funnel. So I'm going to clean up some part. So here is the ring I'm gonna use. Make sure that the ring is also tight enough. So here, now I'm going to wash this. And while I was pouring, my magnet is gone inside, so I can use this fishing rod to take out my magnet. chamber here, and definitely I'm gonna use more ethyl acetate, separate my compound from the aqueous part to make it dissolve. And now I will do this thing, and the rule is you can put your this thing on your palm and then invert this and see it is not leaking, so that means it is good, and hold it, and with the 3 finger you can take this, and once it is inverted, make sure that you open the vent. You will hear the hissing sound, that is releasing the build up pressure. So initially while it is open, do not shake up and down, just shake like this, swirling, so that the neutralized or pressure can go out. And then once it is done, then close it, and then just do a shaking like this, and definitely at least open this vent out. Okay, release it and do it again and again, and then invert it, but I will not invert it completely because I need to take out the magnet from here. So from the bottom, the fishing rod is not coming out, so I'll hunt down by magnet, and this is here. And now, since it is coming from the organic solvent, so I'll wash with ethyl acetate. So my magnet is out. I'll keep it. Now I'll let it separate out 2 layer. Once it is separated from 2 layer, then I'll just remove the aqueous layer, and I will collect the organic layer in a my flask, and I will dry the organic part with the anhydrous magnesium sulfate to dry the organic part completely. Then I will filter it in a round bottom flask, and I'll remove the solvent with the rotoware. And once the rotoware is done, then I'll collect that crude in a small vial, pre-waved vial, and then I do the rotoware again. Like I have definitely from the big flask to transfer it in a small vial, you need to dissolve with the minimum amount of solvent a couple of times, and whatever the solvent is required, you can just transfer it in a vial and do the rotoware with the vial. And once everything is transferred there and the solvent is removed by the rotoware, then you can put in the pump to dry it more to get the amount of crude you are getting. And one important thing you have to remember while you are collecting the organic versus the aqueous layer, in many cases, in many reactions, sometimes your compound can stay with the aqueous layer for some weird reason, or like some solvent case. So in that case, do not throw any part during extraction. Do not throw away before you get your estimated or expected amount of your crude. So that's why always, like as a chemist, you should be careful before throwing out anything from during extraction, because you never know, like if you are losing your compound from there. So once you get the organic part all like taken care of by rotoware and like and pump, and if you measure your crude, and if you see like, okay, I should have that much crude, or I should have that much product, like you can always calculate the mass expected and the yield. So I will explain in my another video like how to calculate the mass expected and how to calculate the percent of yield, what are the limiting reasons. So in my next reaction in my next video I'll try to show those theoretical calculation parts. So yes, that is a extraction process and the workup process. So hopefully it will help you to understand how to do the like extraction or workup with the Schlenck tube reactions, or like from any other reactions. Basically the extraction part is same, And if you want to understand more or like basic information or like theoretical background or like how to choose the solvents and like TLC thing, many other things, just watch my previous videos on TLC and also like extraction. It will help you a lot to understand the chemistry process while you are working. So for now, I think it is enough for today, and I hope it will help you a lot. And if you like my video, then please subscribe my channel and also give a like button and bell button to get the update. Bye now.